Welcome, class, back to Chapter 9, Rhythms Originating in the AV Junction, Lecture Part 2. Today, we will discuss junctional rhythms, accelerated junctional rhythms, and junctional tachycardia. Junctional rhythms is a rhythm that originates in the AV junction at its inherent rate of 40 to 60 beats per minute. It is usually an escape beat. The location of the P wave is dependent on the region of the AV junction in which the impulse originates. Because remember, depending on if it's high, low, or mid, depends on how the P wave will be deflected out into the rhythm strip. Just a side note, junctional rhythms occur whenever the SA node fails to conduct an electrical activity. When this happens, one of the backup pacemaker sites takes over, which is the AV junction, which is the next pacemaker. Junctional rhythms have a criteria or characteristics of being its rate. It's anywhere from 40 to 60 beats per minute. Its regularity is regular. P waves can be inverted or hidden inside the QRS. Your PR interval, if there is a P that precedes a QRS, will be less than or equal to 0.12 seconds. Your QRS will be less than or equal to 0.12 seconds. Causes of a junctional rhythm are vagal stimulation, hypoxia, sinus node ischemia, and some type of heart disease. Adverse effects for a junctional rhythm are potential for decreased cardiac output at a slower heart rate due to the fact that your heart is beating at a slower pace. Your cardiac output can become decreased, meaning it won't get that big atrial kick to where it deposits the last drop of blood out of the atrium, due to the fact that your SA node is no longer functioning. It's your AV junction, and sometimes, depending on where the impulse originates from, you might not get that last kick. Treatments that are used to correct junctional rhythms are atropine, considered oxygen, whole bradycardia inducing medication. Some might be considered for a pacemaker. You also might be giving an infusion of epinephrine or dopamine. This is what a junctional rhythm looks like. So, as you can see, this particular junctional rhythm, its P's, there are no P's. It goes into R, S, T. R, S, and you just happen to see a P that precedes after your QRS. As you can see, trying to mark them here. Your P is after your QRS, and then you have your T wave right there. And that is a junctional rhythm. The next rhythm we'll talk about is your accelerated junctional rhythm. Your accelerated junctional rhythm, this rhythm originates also in the AV junctional tissue, producing a retrograde depolarization of the atrial tissue, and at the same time stimulates the depolarization of the ventricles. If the SA node slows down, the AV junction can escape can take over as a pacemaker, or at or an irritable site in the AV junction can assert control from the slower sinus node and become the heart's pacemaker at a faster than normal rate. The characteristics or criteria for an accelerated junctional rhythm are as stated. Your rate can be anywhere from 60 to 100 beats, meaning basically it almost looks like a normal sinus rhythm. The only difference is your P's will no longer be at the beginning. They may be at the end or within your T, but it still pulsates out like a normal sinus rhythm if there is any P's. Regularity is regular because it is pulsating at a steady, consistent beat. Your P waves may be inverted or hidden inside your QRS if there is any P's. If a P happens to proceed before our QRS or precedes QRS, your PR interval will be less than or equal to 0.12 seconds. Your QRS still falls within norm, which is less than or equal to 0.12 seconds. Causes of an accelerated junctional rhythm are due to heart disease, stimulants, or caffeine. Adverse effects, there are usually none because it is still beating at a consistent beat. It's just that instead of PQRS, your AV junction is now sending out the impulse. And what's happening is as the electrical impulse is going down into the ventricles, is also a little stimulant is also going back to the atrium. So they kind of depolarize kind of simultaneously at the same time. So there is no adverse effects for it. Treatment, there is usually none. Unless they just remove the causes of the accelerated junctional rhythm, such as if you are a consistent coffee drinker, they might tell you to either stop drinking coffee or switch you to decaf. If you're a smoker, they'll tell you stop smoking and etc. They'll remove the cause. What causes it is what's going to be removed to correct an accelerated junctional rhythm. And the last junctional rhythm we'll talk about, I'm sorry. Here's an example of an accelerated junctional rhythm. As you can see, we just go, it's resting, and then all of a sudden you see RS waves, RST waves, especially in this particular rhythm example. You have this long resting phase, and then all of a sudden you get a RST. It almost, like I said, it almost looks like a perfect normal sinus rhythm, other than the P is missing from the rhythm. The last junctional rhythm we'll talk about is the junctional tachycardia. The junctional tachycardia is an irritable spot in the AV junction which has taken over as the pacemaker, and the heart rate is very rapid. This is usually a result of absorption. Junctional tachycardia is best called SVT or supraventricular tachycardia. Only due to the fact that there are no visible P waves. So it kind of almost looks like a SVT. It goes really, really fast. But remember, junctional rhythms can antegrade or retrograde an impulse for it to form a P. So your P might not show up at the beginning, but it might show up at the end of your QRS or within your T wave. That's the only difference. So if you don't see a P at all, then it's a SVT. But if you do happen to see a P that's after the QRS or within your T wave, then you have a junctional tachycardia. Remember that. If no P's are visible, then it's a SVT. If there are P waves that are visible that show up after your QRS, or buried within your QRS, or buried within your T wave, then it is a junctional tachycardia. Your rate for a junctional tachycardia is greater than 100 beats per minute, meaning 101 and above. Regularity is still regular because it still will pulsate out at a normal, consistent rate. Your P waves may be inverted or hidden within your QRS. If it so happens that it has a P that precedes a QRS, meaning before your QRS is formed, it'll be less than or greater than 0.12 seconds. Your QRS will still be within normal rate. It'll be less than or equal to 0.12 seconds. Some causes of a junctional tachycardia are digitalis toxicity, heart disease, stimulant, systematic nervous system stimulation. Remember that's your fight or flight stimulation. Adverse effects will be decreased cardiac output due to it going at a higher, faster rate. It doesn't really have time to take that last step because guess what's happening? Another impulse is going through at that same time. Some treatments that can be given to someone who's experiencing junctional tachycardia is they'll be given either a beta blocker, a calcium channel blocker, might be considered for oxygen, or they might be given cardioversion if they are unstable. Only if they are unstable will they be given cardioversion. This is an example of a junctional tachycardia. And if you look at it really, really good, and I'll try to mark them, but if you look right here, you'll see there's a P before the T. Remember I said if there's no P, then it's a SVT. If you see a P after the QRS, then it is a junctional tachy. And I'm not going to circle them all, but you kind of get the idea of where I'm going. So, no P, SVT. Have P, junctional tachycardia. Right. So let's take a look at this example, and I'll work a couple with y'all the best way I can. Let's take a look. First of all, we have to always remember chapter 6. We always have to ask ourselves those 5 questions. Question number 1, are there any QRSs? Yes, there are. Yes, there are QRSs. The next question, or should I say part A of question 1 is basically describing how the QRSs look. Are they wide? Are they narrow? Are they look the same? Are they up? So looking at this rhythm, for the most part, these QRSs are uniformly shaped, meaning they all pretty much look the same straight across. Our regularity is regular. Our heart rate, which we have to figure out our R to R. So that's 5, 10, 11, 12, 13, 14. Let's see, that's 4 little blocks. 4, 5, 10, 14, 15. So this one will be 1500 divided into 15, which for once I forgot my calculator. Let's see. Let's do it long form then. I'm gonna have to do it freehand. So if we have 1500 divided into 15, so it's 100 beats per minute. So our heart rate is 100 beats per minute. Well, are there any P waves? No, NA. Let's take a look. Let's really, really look. I don't see any after. I don't see any inverted, but our heart rate is 100. So NA. So therefore, we don't have to figure out our PR interval because we don't have any P's. So we would put NA. Our QRS looks like to be one block wide. So our QRS is 0.04 seconds. So based off of our interpretation, we have a rhythm that is regular. We know there's no premature beats, so PJC is out the question. Our heart rate is 100, so the junctional Brady is out the question. Junctional rhythm says our heart rate has to be what? 60 to 100 beats per minute, correct? Our heart rate is just at 100 beats per minute. Our regularity is regular, and we have no P's. And so let's read our criteria for a junctional rhythm one more time. So if criteria for a junctional rhythm is heart rate has to be 40 to 60 beats per minute. So we know that's not it because our heart rate is what? 100 beats per minute. So the next thing we have, our criteria is accelerated junctional rhythm. Aha. Accelerated junctional rhythm, its heart rate is anywhere from 60 to 100 beats per minute. Our heart rate is 100 beats per minute. Our regularity is regular. We can either have an inverted P, an absent P, or a P that is after the QRS. Well, in this one, we have an absent P. And our QRS has to be less than or equal to 0.12 seconds. Less than or equal to 0.12 seconds. Phew! Can't get that zero out. So our interpretation for this particular rhythm strip, number one, would be accelerated junctional rhythm. Let's go through one. Okay, so let's work on this rhythm. This rhythm, as you know, we got to go back through our 5 questions as far as interpretation. So based off of this, we have a regular rhythm. Are there any QRSs? First step. Yes, there are QRSs. Our next question is description of the QRS. Are they uniformly shaped? Are they narrow? Are they wide? Well, in this particular rhythm, we wouldn't say that they are uniformly shaped because some of your S waves are shorter than others. But they are narrow. So we would say QRS complexes, yes, and they are narrowly shaped. A regularity based on this rhythm would be regular with a premature beat where the premature beat is happening right here. So we did our QRS, we determine our regularity, which is regular with the premature beat. Now it's time to calculate our heart rate. So from this R to this R is 14 squares, little blocks. We're going to take 1500 divided into 14. Our heart rate is 107. Heart rate is 107. Are there any P's? Well, Yes, there are P's right here. Sorry for my little circles. All right. So yes, we have P's. So for every QRS, there is a P wave, and it's married to the QRS. So yes, we have P waves, and they are married to the QRS. So therefore, now we can figure out our PR interval. So our PR interval, remember, goes from the beginning of P to the beginning of Q, but we don't necessarily have a Q. We have an understood Q, so it'll go smack dab in the neck flesh to your R wave. So if we go from the beginning of P to the beginning of R, we have 1, 2, 3, 4, 4 little blocks. So 4 times 0.04 would give us, no, can't be right. Sorry. Look at the beginning of P. I'm sorry, y'all. It is only 3. I counted one too many. 3 times 0.04 equals 0.12 seconds for our PR interval. Our QRS is only 2 blocks. So we would take 2 times 0.04, which equals 0.08 seconds. So based off of our calculations, what we have so far, because we answered all 5 questions. So yes, we have QRS complexes. They are narrowly shaped. Our regularity is regular with a premature beat, and it gave it away right there with the regularity. So therefore, we have a PJC. But remember, I said also PJC's heart rate depends on its underlying rhythm. And being that its heart rate is 107, and we have P's that are preceding our QRS's, we have a sinus tachycardia with a PJC. But if you just write down PJC, you are not wrong. If you name the whole interpretation, it'll be okay. But if you just put PJCs, I still won't mark it wrong. I just want to make sure you understand that premature beats are what hiccups in a normal beat. So I need you to get in the habit of naming the underlying rhythm. So in this case, the interpretation for this is a sinus tachycardia with a PJC. All right. Now this concludes the lecture, or the second part of chapter 9 lecture. If you have any questions or you want me to go over a few more problems before your test on Tuesday, I believe, shoot me a text or a message through a metal or on my phone, and I'll be glad to set up another demonstration or another PowerPoint where I'll go over some more rhythm strips, and I'll also do a chapter review at that same time also. Therefore, you get 2 birds with 1 stone. I'll work out a few more rhythms with you, get you to understand how it works out and how you can tell and work them out. And you'll also get a chapter 9 review all at one time. This concludes chapter 9, Junctional Rhythms, part 2 lecture. I hope this helps you out a lot, and you have a nice day.